for the presentation, and thank you very much to be here for the third time. For me, it's a very pleasure to be sharing time with the students that they love their projects, and I love a lot the research and to share some of my ideas for the different team that they are working on. So I hope that I could help all of them with my suggestions. If not, well, it's a pity. Well, now, I'm going to present, as Nacho said, the economy of it is related to the ultra low density base that I have started 5 years ago. And part of this, one of the objectives is to analyze the economy of maize crop at low plant density, especially with the presence of tillers in nitrogen economy. As a context, as Karina told you, Argentina has suffered a very high increase in corn production during the last decade. That is the symbol, the red symbol, show you the increase of total production in Argentina during the last decade. That has changed a lot from the period before. The rate is very high, almost 3 times greater during the last decade than the previous before. And as you know, total production is determined by two components, the area cultivated with corn and corn grain yield per unit area. So this expansion, no, this increase in total maize production came from grain yield, periods, but is related to the drastic increase of during the last. Million hectares. So national maize production doubled in the last 10 years, mainly due to the increase of the cultivated area. So if you think about the area where maize can be performed, here in Argentina, we can find that this is in the in that period, but also we have symbol. Also, we have different in available saltwater content. I show the different available saltwater content by mainly determined by soil tester. And as a function of this is the map of grain yields. This is the mean grain yield at early and late sowing days and by the variability. And here you can show the maize production is conducted under different water and thermal regimes that is reflected in the level of grain yield, but also in the variability of grain yield, interannual variability of grain yield, and also the variability among regions. Excuse me.
The screen. So let's do this. We are between family and friends.
We have that again, no?
No. I think that we can just, the main point is, can you check if we are sharing? Let's make sure that, because if not, it looks like you are not sharing the screen. So let's see. Now, yes? Okay.
Well, so as a summary for the audience that is in remote audience, maize has expanded to a wider. This is the main production, the most productive area, and maize has expanded towards other areas with lower level of rainfall, with different climate regimes, and is reflected in the different grain yield attained and interannual variability of grain yield. One thing that I not mentioned is most of the maize production in Argentina is conducted under rainfall condition, no irrigation. So, For example, you can see here in this map, the different harvesting. Maize producing from the north to the south of Argentina and from the south to the inner part of the country. And in that situation, if you can map, this is the most productive area, and it is showing that in this area, or few percent of the area is sold at and in the expanding of the newest area, most of the cultivated and on late sowing date, because it had the benefit of a better water balance around flowering, because flowering takes place at the end of the summer with higher water demand. And the other thing that changed in this marginal plant population. Plant population in the main crop production area, or the most productive, is more or less higher than 7 plants per square meter, and in the other area, it declined, arriving also to lower than 2 plants per square meter. So in this newest scenario, maize can show different phenotypes. For example, here you can show, this is the main shoot, and tillering phenotype. This is the typical prolific phenotype. And also here you can see the tillering phenotype, almost tillers, and each tiller may have one harvestable ear. So the different practices that have tended to decrease plant population density to stabilize grain yield and the late sowing date may promote the expression of the different phenotypes that are not expressed in the most productive area, because plant population density inhibits the expression of those processes. So, what have we learned about tillering? Yeah, from Rachel, Diego Rotilli, and Franco, for example. Well, this is a function of plant population density at 2 sowing days later only. And you can see that the expression is more or no. The expression with very low always the vertical to look very low. Nutrients that promote vegetative growth, and tillering is vegetative growth. But what are the Franco? The nutrients may have to send to the lower base of the plane to the and promote the emission of those tillers. If plant have this is the more and below plant. The other point is the fertility of tillers, not only the expression, the growth, and the fertility. It's another one. I believe that was, well, the fertility of the tiller is related to the conditions around flowering. And in this case, we have simulated with Diego Rotilli for different locations that have different proportion of the different types of water stress. This is the best location and the worst location. This is the frequency of no frequency of stress or light stress, water stress, and higher water stress. And particularly, the worst condition for water stress are the red and the orange color. So it's a higher frequency, lower frequency, and this frequency increase as the plants have 1 tiller, 2 tiller, are simulated. So, independent of the location, you can X is showing the differences between the kernel number per square meter when have tillers and when no have. So the difference that tillery crops have and the vertical line shows the zero value. So if you follow the red arrow, we can say that increase the proportion of cases that tiller had a positive effect, increase. And it increased a lot when conditions are better for the expression. When the weather, the groundwater stress is lower than in this location. So the expression of tiller is not only determined by plant population density, plant growth at early stages, but always also condition for the fertility of these crops. Okay, but another revision of Diego Rotilli was a recent paper that he had. Well, also, no, Russian. Oh, yes. No, it's not. Ah, yes. Excuse me. He has compared publication where the tillering was manipulated. So, of and okay, and it as imagine the so the point is can say that all in all tillering has a positive effect on drainage, no penalty. But in some conditions like this, very different than what we have in mind, or our farmers have in mind, that always tillering penalize grain yield. In some conditions may penalize. We have learned that those conditions are the typical that tillers have a higher growth rate, but finally they arrive without ears. In that condition, there is a penalization to grain yield. But if they add ears, it has a positive effect. And I mean positive. This is the analysis that have performed Diego, but also with the network. Here is an example of the differences between the tillering crop versus the non-tillering crop. It's another phenotype, the flex phenotype, no expression of tillering. Negative values is better the flex than the tillering genotype. And this is the range of environment analysis. And we have a lot of cases that tiller crops have a higher grain yield than the flex, and another environment, a higher potential environment, than flex had a better performance than tiller crop. And some of them done some negative effects. Okay? Well, so what happened with nitrogen economy? We were interested to analyze and to explore the nitrogen economy of these tillery crops, because all of the information of nitrogen dynamics were published in higher density that we have analyzed it, and in phenotypes that have no expression of tillering or prolificacy. a typical flex 1 year per plant and at higher plant density. And all the curves of nitrogen obtained, nitrogen use efficiency were determined for this sort of phenotypes. Only the paper from Martin Parco have documented what happened with prolificacy on nitrogen economy, but no one with tillering. So we start with Nacho also studying this process of nitrogen economy based on a data set that a student that I conducted with Karina and Diego. We are the advisors. This is 2 plants without tillers. We are now 2 plants with tillers. Without and with 2 tillers because it's higher, but not with less and higher nitrogen. Here, the express the effect of fertilization on total and final plant biomass. Here, the same with nitrogen uptake. Always. And this is the same for nitrogen uptake, and this also the increase of nitrogen uptake. Here without tillers, here with tillers, you can see that the presence of tiller has a higher effect on nitrogen uptake because it has a higher effect on crop growth. Okay, and well, this is the other plant density. So at low density, 2 plants, the presence of tiller increase crop biomass, nitrogen uptake. Okay, if you the tiller, but also a low plant density is a positive effect of fertilization in a soil that starts with 70 kilograms per square kilograms per hectare. Hectare, isn't it? Okay. So, well, here we indicate that nitrogen to produce biomass is similar between the tillery and tillery crops. It's no a penalty on their efficiency to produce biomass, but it's a decrease of nitrogen efficiency to produce granule, and this is related to the lower index of the shoots that came from tillers of the year of tillers. Yes, here this is the harvest index of main shoots based on shoot biomass at physiological maturity. This of tiller shoots that may have lower harvest index. So when we compose the crop, here we have crop cover index, yes, that if you don't have tillers, crop cover index is higher than when crops have tillers, okay? Because tiller reduce the crop harvest index. So as they reduce crop harvest index, nitrogen use efficiency to produce granule is lower in tillery crops, okay? So the other thing that we found is the relation between kernels and crop. Okay. And this trend is mainly sustained kernels of the main shoots and this is decoupled by shoots of tillers. So the negative relationship between crop near and protein is sustained at the crop level, but only is sustained at the main shoot level because tillers it had a lower in harvest index. Okay. Well, and what happened with so here we can see in 2 years of experiment and in different in dark blue and in light blue fertility application. And here we can say that when we have low plant density, it's necessary to fertilize crops to be close to the dilution curve because farmers usually reduce plant density and don't use fertilizers, but they are limiting crop growth. Yes, but the similar is when you analyze, and we analyze the four plant population, the four plant density. Also, we have here fertilized crop, not fertilized crop is below. Well, that's the typical response to nitrogen fertilization, but also concern when we analyze lowest density. Four plant density to two plant density are very low. But they also show positive effect to nitrogen fertilization. But the most interesting things are, well, and this is and the similar for plant densities at crop level. But the most interesting point, and then this is the last one of the last figures, and then we can start with the questions, is when we compare what happened when nutrition of the main shoot and tillers. So here we have main shoot in blue, and tillers in green, below the main. When we add fertilizer, more are mentioned. With the high density, or the four is not high, but the other density, 4 plants per square meter, main shoot, and tiller, no fertilizer. And when we fertilize, the more responsive organ are main shoot and lower response in tiller. So we are thinking that the different shoot order have an asymmetrical competition by soil capture. Probably main shoot that had developed earlier than tillers have determined a higher or a higher growth of roots, and they are depleted the soil. And when the shoots of tillers start to grow, they found a more depleted nitrogen condition. We test again with another parameter very high rate. This is the growth data, and for this growth, we have tillers and main shoot. So there's something that we are trying to explain, to make deep analysis or another experiment to solve this difference. No. One of the points that possibly is related to the different response, one is the different ability of shoots to acquire nitrogen, and the other is a different plant structure of tillers and main shoots. And so Carlos have performed the measurement of the leaf-shoot ratio of each organs, and he found that this is the leaf-shoot ratio in biomass. We have also data to do it for nitrogen, but at early stage, main shoot have a higher leaf-shoot ratio than tillers. Tillers have a lower leaf-shoot ratio. Probably the different compartments of nitrogen is changing, and we could think that probably we have to develop a nitrogen dilution curve for tillers that is different than for crop. And crop normally was the dilution curve of crop was normally performed with main shoot, not included tiller. So we have to test it. Okay? Understand? It's clear? Yeah? Well, and finally, at chart 2, and when we again combine the different shoots and we made the determination at the crop level, all of them are merged. So the NNI at crop level is able to describe the different crops without and with tillers. These are crop conditions without tillers and crop conditions with tillers, and the merge and the NNI better describe variability among crops with different tillers. So conclusions and questions. At low density, tiller increase crop and uptake, crop grow with a similar nitrogen use efficiency, physiological nitrogen efficiency to produce biomass, increase yield, increase nitrogen uptake. However, nitrogen use efficiency to produce kernel are lower because the lower harvest in the tillers, probably nitrogen use efficiency, the agronomic is lower, okay? Because this is lower based on the lower harvest index. The other point is despite low density, soil and offer may be limiting crop growth and grain yield of tillering hybrids, especially affecting tiller growth and tiller fertility. NNI at R2 adequately describe grain yield variability of tiller, main shoots, and crop at the shoot level and also at the crop level. At the shoot level with different function, at crop level, a similar function for crop without or with tillers. And the question is if the critical dilution curve universal for both this is if the dilution curve is universal for main shoot or tiller. If not, could it imply biomass? We think that yes, we have to explore more about this. With, for example, which is the relationship between nitrogen in leaf and nitrogen in shoot biomass. Would it be necessary to adjust a new critical dilution curve for this shoot order? I hope that if we have a new doctoral student with Nacho, we could study this. And is the low productivity of tiller mainly nitrogen deficiency? Does good crop expressing this plasticity trait have greater nitrogen needs to express the yield potential under optimal condition? Is a problem the nitrogen amount, or we have to think about how to add the nitrogen for overcast the lower ability of tiller to capture the nitrogen. We don't know. We have to test it. Well, thank you for your attention. This is the link of the network. A lot of information of the last side of the compound is the